Okay, we're going to do a weak acid strong base calculation, take 2. Since yesterday was a little bit confusing, but that's normal. First time we do this process, it's completely normal. So with that being said, I'm going to work through this one on this side of the paper, and then I would like you to do the other side, which is going to be the opposite. It's going to be a weak base and a strong acid, and I want you to turn that in by the end of the class period. Okay, so here we go. Before we ever start, let's look at what we have in terms of our weak acid. We have HF, and it gives us our Ka value. And if I do 50 times 0.1, I get 5 millimoles. Okay, and I'm dealing with 0.1 of my strong base. So before the titration begins, it's our standard thing. Remember, we have our rice table. If we were doing it that way, although we at this point are pretty good at experts of saying that Ka is going to be equal to x squared over 0.1 minus x. We're going to say neglect, so we're going to say that's approximately equal to x squared over 0.1. So when we solve for x, which is the equivalent to our hydrogen concentration, we get 0.0085 when we plug in that value of 7.2 times 10 to the negative 4 right there. And then we are going to take the pH for that would be the negative log of 0.0085. And so we would need 2 decimal places in our pH, and we would get 2.07. So before we ever do anything, before we add any acid, it's just straight up acid equilibrium problem. So now we are before the half equivalence point. So we're still in the buffer region. So we're going to say what happens when we've added 15 milliliters of the hydroxide. And so when we do that, 15 times the 0.1 is going to be 1.5 millimoles. And so again, we'll go back to that H plus OH minus is our problem that we're making here. And I'm going to see if this maybe makes a little bit more sense the way that we did yesterday. So we know we have 5 millimoles here, and we have 1.5 here. So they're going to react, and we're going to run out of hydroxide, right? And so then that's going to leave us with 3.5, okay? So when we are calculating our new acid concentration, we're going to have 3.5 over our new volume of 65, and our base concentration is going to be originally 1.5 over our new volume, okay? The way we did it yesterday may have confused you by doing out the volume, so we're just going to go back to this way. If you liked the way I showed you in the notes, you are welcome to use that as well. Okay, so now we're going to use H plus is going to be equal to Ka over A and B concentrations. Okay, so now we would get 7.2 times 10 to the negative 4 times 0.053 over 0.023, and we get that our hydrogen concentration is equal to 0.0017, and then pH would be equal to the negative log 0.0017, and so we get a pH of 2.77. Okay, so that's how we would do it before we reach that half equivalence. Okay, at the half equivalence, it's going to look different, of course, because that's going to be easy. I'm going to erase this so I have room, and I'm going to scroll this up so I can, hold on, I'm trying to do this. Sorry for the delay. Scroll up. Okay. And then I'm going to say at the half equivalence point, 25 milliliters. Of course, that is 2.5 millimoles. And so that is showing us that I have neutralized half of the acid. So at half equivalence, remember pH is equal to pKa. And so that is going to be the negative log of our 7.2 times 10 to the negative 4th, which is 3.14. Okay? And now if we were going to go slightly past the half equivalence, but we haven't made it to the equivalence, just to see what that would look like. So we have 30 milliliters, right? 30 milliliters would be 3 millimoles, right? 30 times 0.1. So again, back to the H plus OH minus, making water. We had 5 here. We now have 3 millimoles. And so 5 minus 3 is going to be left over with 2. Our new volume is 50 plus 30 is 80 milliliters. So again, H plus is going to be equal to Ka, and then acid over base. So we need to calculate our new acid concentrations. So still going to have 7.2 times 10 to the negative 4. Our acid concentration is going to be, let's do it over here. I think it confuses y'all when we put it all together. So we have 2 millimoles divided by the new volume is going to be 0.025 molar. And then I said H, that should have been an A. I'm sorry. That's an A. I don't want to confuse you. And I probably just did. I apologize. And then our base, of course, is the 3 millimoles over 80, which is 0.0375 molar. So now we plug that in, 7.2 times 10 to the negative 4, 0.025 over 0.0375. And then we get our hydrogen concentration is equal to 4.8 times 10 to the negative 4. And then we take the pH is equal to the negative log. So then our pH for this is 0.32. Okay, so far those are worked the same, and now we're going to do at the equivalence point in 0.5 along this graph. Okay, so let's erase all that, because erase all strokes. And now we're going to do at the equivalence point. So 50 milliliters means I have 5 millimoles. Okay, this is the part that we got confused on in class. Okay, so we're looking for our basic salt here, and since we started with HF, our basic salt is going to be F minus plus water is going to create HF again plus hydroxide. Okay, so at this point we're 0, 0. We don't care about this, and we have to go calculate what we have as our concentration of our F minus. Okay, I kept the example the same in terms of molarities. Okay, so we have 5 millimoles that we need, and it required 50 mils. We had to figure that out yesterday. That means because we have 5 millimoles, that we also have 5 millimoles of our F minus. Okay, we need to divide by the new volume of 100 milliliters. That's 50 from the base and 50 from the original acid. And that gives us 0.05. So we're going to put 0.05 right here. Okay, of course that's going to be minus X, X, and X. And then at equivalence, it's 0.05 minus X, X, and X. Because this is a basic salt, because it created this right here, it's a basic salt, that means we're going to need a Kb. And that's going to be equal to Kw over Ka. So 1 times 10 to the negative 14, and 8.4 times 10 to the negative 4 is going to give me a Kb value of 1.4 times 10 to the negative 11. And then that is going to be equal to x squared over 0.05 minus x. We're going to say that's approximately equal to x squared over 0.05. And then when we do our math, we will find that x is equal to our hydroxide concentration at this point, okay? Because if we go back to that, let's just make sure you understand why it is that. Kb is going to be equal to HF over hydroxide over the F minus, okay? And so when we solve for X, we're solving also for the HF concentration at this point, but that doesn't matter. And then that, let's go back to our green. So that means when we get our X value, it's going to be 8.4 times 10 to the negative 7 molar. So we're going to take our negative log of this, and that's going to give us a POH of 6.08, and then therefore our pH, when we subtract that from 14, will be 7.92. So our equivalence point is above 7 here because we are dealing with a strong base and a weak acid. Okay? And then our last point along this line is, let me erase all that and move it up. Our last point along this line is going to be after the equivalence point, at which point we have added 60 milliliters of NaOH, which means we have 6 millimoles of hydroxide at this point. So then we know that hydrogen started with 5 from the beginning of the problem, and then we have hydroxide has got 6. So 6 minus 5 is 1 millimole of hydroxide that is left over. Let's go ahead and divide that by our new volume of 110 milliliters, 60 plus the original 50, and that's going to give me a concentration of 0.0091 molar. So now POH equal to negative log of 0.0091. It gives me a POH of 2.04. Therefore, pH is equal to 11.96, which is what is in line of what we would expect because we just over titrated with too much base. So we just basically have hydroxide contributing to our pH. And that hopefully helped clear some things up from yesterday. Like I said, I'd like you to do the other side yourself because it's going to be a weak base with the strong acid. And the only thing I want to remind you of is beforehand, when you're doing like at point A before the titration begins, that's going to be your hydroxide concentration. Don't forget to subtract it from 14. And that is it.